Now, in this lecture, I will give you a proof to the Pythagorean theorem. The Pythagorean theorem relates to right triangles like this triangle. A right triangle is a triangle in which one of its angles is 90 degrees. This angle is 90 degrees, so it is a right triangle, and it actually says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So c squared equals to a squared plus b squared. Again, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. C squared equals to a squared plus b squared. In order to prove the theorem, I actually made a copy of this triangle here, and I did it by drawing a straight line in size of b. So we have a straight line between A and B, and then I raised a perpendicular to side B in size of side A. So the angle between side A and side B is 90 degrees. So in this way I created two triangles that are equal, that has two sides that are equal to each other, because side A in the right triangle equals to side A in the left triangle, and side B in the right triangle is equal to side B in the left triangle, and also the angle between side A and side B in the right triangle is equal to the angle between side A and side B in the left triangle. So we can say that the right triangle coincides to the left triangle, or those triangles actually coincides to each other because of the fact that they have two sides that equal to each other, and also one angle that equal to each other. So because of that fact, these two triangles coincides to each other. Okay. Suppose that we will call to the angle between side C and side B in the right triangle alpha. So 1 minute please. So suppose that we'll call to the angle between side B and side C in the right triangle alpha. Then the angle between side C and side B in the left triangle will be also alpha, according to the rule. Corresponding angles between coincides triangles are equal to each other, and for that reason, if this side is side C in the right triangle, this side in the left triangle must be also C, because of the rule of corresponding sides in coincides triangles are equal to each other. Okay, these two triangles coincide to each other, and for that reason they have corresponding sides. Side C corresponds to side C here, and for that reason they are equal to each other. And suppose that we will call to the angle between side A and side C x. We will call it x because we don't know the size of it, but we do know that the sum of the angles on a triangle is 180 degrees. So we can say that alpha plus 90 degrees plus x, alpha plus 90 degrees plus x equals to 180 degrees. So we will write it down: alpha plus 90 degrees plus x equals to 180 degrees. It is true for every triangle in the world. The sum of the angles in every triangle is 180 degrees. So you can say that alpha plus 90 degrees plus x equals to 180 degrees. Now we can subtract 90 degrees from both sides of the equation. We'll get that alpha plus x is equal to 90 degrees. As you can see here, alpha plus x equals to 90 degrees. Now we'll subtract alpha from both sides of the equation, and we will get that x is equal to 90 degrees minus alpha x equals to 90 degrees minus alpha. If we look at the middle triangle, we actually don't know the size of this angle, so we will call it y. But we do know that the sum of the angles in one side of a straight line equals to 180 degrees. If we look in this straight line that passes along A and B, this straight line has two sides. It has the bottom line and the bottom side and the upper side. And the sum of the angles in the upper side is 180 degrees, and so is the sum of the angles in the bottom side. It is also 180 degrees. In this case, we have only one angle in the bottom side, and it equals to 180 degrees. But if we relate to the upper side of the straight line, then we can say that x plus y plus alpha equals to 180 degrees. So the sum of the angles on the upper side of a straight line equals to 180 degrees. But we know that x equals to 90 degrees minus alpha. So we can substitute x by 90 degrees minus alpha. So we got that 90 degrees minus alpha plus y plus alpha equals to 180 degrees. Now alpha minus alpha plus alpha equals to 0. So we can eliminate alpha from the equation. So we got that 90 degrees plus y equals to 180 degrees. Now we will subtract 90 degrees from both sides of the equation, and we will get that y equals to 90 degrees. Okay, y equals to 90 degrees. So the middle triangle is a right triangle because it has one angle that equals to 90 degrees. So actually you can say that all the triangles in the picture are right triangles. The right triangle is the triangle that is in the right side of the picture is a right triangle because this is actually the sentence that we want to prove, that in every right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, c square equals to b square plus a square. So from the beginning we have here a right triangle, and we found out that the middle triangle is also a right triangle, and actually the left triangle is a copy of the right triangle, so it is also a right triangle. we built it like this. Actually, when we raise the perpendicular to side B in size of size A, in size of side A, so the angle here is 90 degrees. So all of the three triangles are right triangles. Now we can see here a trapeze. A trapeze is a square with two sides that is parallel to each other. Side A is parallel to side B, so for that reason this is a trapeze. A square with two sides that parallel to each other is a trapeze. So we have here a trapeze. Now we will calculate the area of this trapeze in two ways. So we will create two expressions, and then we will compare expression 1 to expression 2. Of course they are equal to each other because it will be the area of the trapeze that expressed in two different ways, and from this third equation we'll derive the Pythagorean theorem. Okay, so we will start in the first step and we will calculate the area of this trapeze in a first way. We will call the area S. Okay, the area of this trapeze will be S, will be called S, and so S equals to the sum of the parallel sides. A is parallel to B, so the sum of A plus B, so the sum of it is A plus B, times the height of this trapeze that is also A plus B, and all is divided by 2. So the first way to calculate the area of the trapeze is actually, we can say that the area of this trapeze equals to the sum of its parallel sides, that is A plus B, times the height of the trapeze, that is also A plus B, all divided by 2. And the second way to calculate the area of this trapeze is actually by saying that the area of this trapeze equals to the sum of the areas of the triangles, of the three triangles that the trapeze contains. This trapeze contains three triangles, and the sum of the areas of those three triangles will be the area of this trapeze. The area of this triangle plus the area of this triangle plus the area of this triangle will be the area of the trapeze. So S equals to the area of the right triangle, that is its base times the height to the base is A, times the height to the base is B, all divided by 2. So the area of the right triangle is A times B divided by 2. And the area of the middle triangle is the same formula, that is the base of the triangle times the height to the base divided by 2. The base of the triangle is C, times the height to the base is also C, all divided by 2. So the area of this trapeze is C times C divided by 2, or C squared divided by 2. And the area of the left triangle is also the base of the triangle times the height to this base. So the base of the triangle is B, the height to this base is A, all divided by 2. So the area of the left triangle is B times A divided by 2. So in total, the sum of the areas of the left triangle plus the area of the middle triangle plus the area of the left triangle will be the area of the trapeze. I will repeat, the area of the right triangle plus the area of the middle triangle plus the area of the left triangle will be the area of this trapeze. So the second way to calculate the area of the trapeze is to calculate the area of the three triangles that the trapeze contains, and the sum of the areas of those three triangles will be the area of the trapeze. So the area of the trapeze is the area of the right triangle, that is A times B divided by 2, plus the area of the middle triangle, that is C squared divided by 2, plus the area of the left triangle, that is B times A divided by 2. Okay, so this is the second way to calculate the area of the trapeze. And of course, if expression 1 is equals to expression 2, because it's the area of the trapeze that we calculated in two different ways, so we will create a third equation that says that expression 1 equals to expression 2. Okay, and from this equation we will derive the Pythagorean theorem. So expression 1 is A plus B times A plus B, all divided by 2. So expression 1 is the area of the trapeze, and it equals to expression 2, that is also the area of the same trapeze that is calculated in a different way. So expression 1 equals to expression 2, and the expression 2 is A times B divided by 2 plus C times C divided by 2 plus B times A divided by 2. Okay, so the third equation says that expression 1 equals to expression 2, or in other words, the area of the trapeze as we calculated it in the first way equals to the area of the same trapeze as we calculated it in the second way. So here we can multiply the two sides of the equation by 2. So after we multiplied it by 2, we got that AB plus C squared plus BA equals to AB squared. And we know that AB plus BA is 2AB, and C times C is C squared. It's a mistake. It is AB plus C times C plus BA, and AB plus BA is 2AB, and C times C is C squared. So we will write it down. Okay, so I already said AB plus BA is 2AB, and C times C is C squared. Now in the left side of the equation we have brackets, so we will open the brackets and do the multiplication. So after we opened the brackets, we got that a times a is a square, plus a times b is ab, plus b times a is ba, plus b times b is b square, all equals to 2ab plus c square. Again, ab plus ba is 2ab, so we will write it down. Okay, as I've already said, AB plus BA is 2AB. Now we have A square plus 2AB plus B square equals to 2AB plus C square. We can subtract 2AB from both sides of the equation. We will get that A square plus B square equals to C square. So the last term is a square plus b square equals to c square, and this is exactly the Pythagorean theorem that says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or c square equals to a square plus b square. Again, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. C square equals to a square plus b square. Okay, so now we can summarize the lecture and say that we had a right triangle, and we wanted to prove that c square equals to a square plus b square, or the square of the hypotenuse equals to the sum of the squares of the perpendiculars. C square equals to a square plus b square. So we made a copy of this right triangle here, and then we actually found out that this angle in the right triangle is 90 degrees, and for that reason the middle triangle is also a right triangle. So we have here 3 right triangles, and then we calculated the area of this trapeze in 2 ways. A trapeze is a square with 2 sides that parallel to each other. Side A is parallel to side A is parallel to side B, and for that reason this is a trapeze. Okay, so we calculated the area of this trapeze in the first way. We actually said that the area of this trapeze equals to the sum of its parallel sides, that is a plus b, times the height of this trapeze, that is also a plus b, all divided by 2. So the area of the trapeze in the first way of calculation is a times b plus times a plus b, all divided by 2. And the area of this trapeze, when we calculated it in the second way, is actually the sum of the areas of the 3 triangles that the trapeze contains. That is to say, it has the sum of the area of the right triangle plus the sum of the area of the middle triangle plus the sum of the area of the left triangle. The sum of the areas of those three triangles equals to the area of the trapeze. So it is actually the area of the right triangle, that is a times b divided by 2, plus the area of the middle triangle, that is c squared divided by 2, and plus the area of the left triangle, that is b times a divided by 2. So the area of the trapeze in the first way of calculation equals to the area of the trapeze in the second way of calculation. Okay, expression 1 equals to expression 2, and we developed this equation, and finally we arrived to the last formula that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, or c square equals to a square plus b square. C square, the square of the hypotenuse, is equals to the sum of the squares of the perpendiculars. C square equals to a square plus b square. Okay, thank you very much.